All right, guys, let's look at expressions, Series B. And we're going to look at evaluating expressions today and also talk about some vocab associated with these. That's really important. Let's dive in. Okay, this first one on the left, we notice it's different from the one on the right because there's nothing on this other side of the equal sign. Whereas the math that is on the right-hand side does have something on both sides of the equal. That means these are two different types of math. They have a specific name. Do you know what those names are? When there's nothing on one of the sides, like this is called an expression. Like this, an expression. Over here, both sides are filled in. That means we've got an equation. So that's an important difference between the two. Notice with an expression, we don't have an answer. Okay, there's no specific answer. Because if I tell you x is 5, x is 10, x is 20, those are all different answers it's going to equal. Whereas for the equation, next week we'll start learning to solve, and x will have some specific answer. There's only one value for x that will make that equation true. So equations, we solve for an answer. Expressions, we can simplify, we can play around with, we can plug in a given value for. All right. Okay, let's talk about some vocab here. Now this, again, is an expression, and it's got three pieces that make up this expression. And all of these guys have the same name. They're called terms. Okay? A term is, I'm not going to say piece. Let's do better than that. A value. In an expression or equation, all of this vocabulary is true for expressions and equations. Separated by addition or subtraction. Okay, so basically those three chunks are three separate terms because there's an add or subtract sign separating each of them. Now, they also have their own names, so let's talk about that. The negative 19y here has a name for each piece of this term. The negative 19 is called a coefficient. I think I'm spelling that wrong. Coefficient. There we go. And the y, of course, is a variable. So we've got a coefficient and a variable, and together you could say that's a variable term. And so the second term up here, negative x, also a variable. And it does have a coefficient. We need to talk about that. Okay. So if we pull this guy over, two things that are really important to notice. Number one, the negative with the x. Okay. That is part of the term. Okay. Notice the brackets go around the sign with each of them. So that negative is with the x. And then second, there's something right here. We have a coefficient. We just can't see it yet. Do you guys remember what it is when you can't see the coefficient? There is one in front of the x. And good job, some of you were saying 1. And that's the case. There's always a 1 in front of any variable that doesn't have anything else written in front of it. So this is also a variable term, and it's got a coefficient and a variable together. And if you don't see the coefficient, it is a 1. Also, include the sign with each one, okay? And then last, there's no variable with that 7, and that is not a coefficient that sits by itself. Co means with something. Since there's no variable, he's not any kind of coefficient. He's got a different name. That value by itself is called a constant, okay? So we have 3 terms, and the first 2 terms are variables with coefficients, and that third term is a constant. All right. Now, what the heck is the point of expressions? Why are we even talking about this? How would we use these? If you need to, pause it so you can get this written down. So let's say you're going on a school trip, and anytime you want to buy a meal on the trip, it's $12. And then everyone that goes on the trip has to pay $5 for the bus. There's just one bus. It costs $5, one bus ride. So we wanted to figure out how much it would cost you to go on this trip. Well, if we said food was F, okay, and it's $12. Let me put that in front. That's where it should go. The location doesn't matter, but this is how you're normally going to see it. 12F plus 5. Okay, this expression tells me however many meals, however many times I want to eat food, I would plug in for F. That's going to multiply with 12, and then I would add that $5 on. That's the total. So let's say Billy is going to eat 5 meals because he's on the football team and he's just crazy hungry all the time. And Tom is only going to eat once because he is saving his money to buy a Buick. So if Billy is going to eat 5 meals, Billy is going to plug in a 5 here. He's going to need to take a whole heap of money on that trip. Okay, so he's going to have 60 plus 5, $65. Do the same thing for Tom. 12 times 1 meal means he's only got to bring $12 plus that 5 for the bus, 17, okay? So that's the idea. An expression allows you to create this kind of generic mathematical calculation, and then you can plug in the variables for the changes you're going to make in whatever calculation and use that same formula over and over again, okay? And when you do plug in, that's exactly what we just did here. We substituted in a value. For Billy, we substituted in 5, and then we calculated out how much he was going to need. We evaluated that expression for Billy's 5 meals. Over here, we evaluated the expression for Tom's 1 meal. And that expression gives us 2 different answers because, again, it's open-ended. You can plug in various values for that variable. That's called evaluating an expression right here. Okay, so what is evaluating an expression? It's to substitute a given value for the variable, and then you now calculate the solution. So if I jump back for a second, all right, so let's practice a little bit. This is our vocab, and then we will do some plugging in practice right after this. Go ahead and answer those 3 questions. Pause the notes here, and then let's answer these 3 questions. Okay, hopefully you've paused and you've already worked this out. Number 1, how many terms? There's 3 terms, okay? If we were going to list them, there's the first one, negative 18y. I'll put a comma to separate. Second one, negative x. Notice I'm keeping the sign with the term. It matters, okay? It's not just an x, it is a negative x. And then here we can write 11 because positive is always assumed. Since it says plus 11, we know it's a positive 11. Those are the three terms. 2, what are the coefficients on the first two terms? So we've got a negative 18. That's the coefficient of the first term. And then what is the coefficient on that second term? Since there's nothing right here in front of that variable, we know something's there. It's always the same thing. And yes, you're right. It's a 1. Now I'm hoping you just said, Mr. A, wait a sec, you did something wrong. If you did, good job. It's negative 1. You always keep the sign with that term. All right, number 3. What is 11 called? It starts with a C, constant. Okay? The way I remember that is because when you plug in different values on a variable, it's going to change what that term equals. But plus 11 will never change by itself. It's always going to be plus 11. It stays constant. That's how I remember it. All right. Now let's do some practice of evaluating, plugging in. Here's one I'll do for you guys. Evaluate the given expression for x equals negative 3, okay? For you to evaluate, they'll give you a value to plug in, and then you do the work. So right here, I'm going to plug in negative 3 for x. And I'm going to put parentheses around it. And this is why. This is important, guys. This negative 2x right here is written together, okay? In fact, this is my best math joke. If negative 2 and x are stuck together, we need to know what they're doing. So I'm going to ask you this. What are two dogs stuck together doing? They're multiplying. Two dogs stuck together are multiplying. Well, in math, it's the same thing. Negative 2 and x stuck together are also multiplying. So if we are not careful and we don't put parentheses, watch what happens. If I just plugged in negative 3 for the x and then brought down the negative 2, that does not look like multiplication to me. That looks like a subtraction problem. To make sure I still know it's multiplication, I have to put parentheses on there. And now it's negative 2 times the negative 3 that we just plugged in for x. Okay? Same thing. This x we're going to replace with another negative 3. And notice there are 1, and inside the x, 2 different negative signs. We need to have both of them written, okay? We don't get rid of that first negative. We bring that one down as well. So notice there are 2 of them, so parentheses. And now we've got what we've seen in the past, minus a negative. We already know how to rewrite that as addition. It just makes things simpler, so we're going to want to do that in just a second. And then bring down the plus 9. Now, this is a really good problem for you guys to notice something. This is multiplication. Negative 2 times negative 3. This is why we went over integers last week. 2 negatives multiply and cancel with each other, or pairs of negatives cancel. We end up with positive 6. Here, in the second piece, we have minus a negative. That pair of negatives cancels. So really, that's just plus 3. And then bring down the plus 9. And now it's pretty much done. 6 plus 3, 9. 9 plus 9, 18. Okay? So what you guys have to watch for is the details when we're plugging in. I intentionally gave you negative 3 for x. When somebody gives you a negative for a variable, you have to watch when you plug it in. It's going to multiply with whatever's next to it, or it might have a subtract symbol in front of the variable, which is going to double up and cancel. You have to watch those details. All right, here's a couple examples for you to try. Pause this, work them out, and then I'll go and do them right now as a solution. You can check your work. Now, if you're being lazy and you're just going to let the video roll and let me solve them, I'm going to do really good on the quiz Friday because of all the practice I'm getting. You maybe not so good. Okay, pause it, do the problems, and then when we're done and I do the solutions, check your work and fix any mistakes. All right, pause. All right, I'm trusting you right here. Oop, we don't want that. We want, yep. Okay, the y I'm going to replace with -4. And again, I'm throwing negatives at you so you guys practice the harder stuff. Since the 8 and the y are stuck together, they're multiplying. To make sure that they're multiplying, I've got to keep a parentheses on there to make it clear. Minus, and then whatever y is, -4. Notice again, just like I did for you guys, there needs to be 2 negatives. If you only had 1, you missed that. That's the kind of mistake you have to practice and learn. And then bring down the -6. All right, now I'm just going to cancel those 2 negatives into a plus, and I'm going to multiply that 8 times -4. I'm running out of room, so I'm going to move over instead of going down. 8 times -4, -32, plus 4. I'm just copying over those terms, and the -6. Now we just finish the problem. And again, I would encourage you guys, just do all the good guys or all the bad guys together. There's a group of bad guys and bad guys, -32 minus 6. We've got -38 plus 4 equals -34. Good job if that's what you got. All right, number 2. I gave you an x squared. Let's see what you do with that. Now, remember last lesson we talked about exponents of integers. Notice here that when you plug in, the x is going to be in parentheses, like everything that's inside of x. So the negative and the 5 are all squared. Okay, so that's going to be, I'm going to do it off to the side so you guys can see that. You're going to square the negative with the 5. That's going to result in positive 25 because those negatives are going to cancel. So here we end up with 25 plus 4 times, again, lots of negatives to make you work with them. 4 times -5 is -20. Hopefully you guys are really seeing. If you put in the time and you learned your integers last week, you're glad. And if not, you're seeing why you need them right now. Okay? We just constantly do multiply, divide, or add, subtract rules. You got to have them. 25 minus 20, well, that's really simple. 5 minus 9. I'm going to rewrite that as addition by putting a plus in front of it. 5 plus -9, -4. All right, guys. I hope that makes sense. We're going to go over this and do some more practice tomorrow. See you.